You know that feeling? You want to take one of these huge, powerful language models and fine-tune it for your own project, but then you see the hardware requirements and it just feels impossible? Well, what if I told you that's not the case anymore? Today, we are going to break down the two techniques that completely changed the game, LoRa and QLoRa. This is basically the story of how we went from needing a supercomputer to being able to fine-tune on a gaming PC. Let's get into it. All right, so let's just imagine for a second. You've got your hands on a massive 70 billion parameter model, a real beast, and you're thinking, I want to fine-tune this thing for my specific need. Sounds awesome, right? But what does it actually take to pull that off? The answer? A truly mind-boggling amount of memory. To do a full fine-tune, you'd need almost 1.8 terabytes of VRAM. No, that is not a typo. We're talking about a huge cluster of the best GPUs money can buy, which would set you back thousands and thousands of dollars for just one training run. Look, this isn't just a little speed bump. This is a giant wall. For the longest time, it's what made serious fine-tuning completely out of reach for, well, pretty much everyone. And that's what we're calling it, the fine-tuning memory crisis. Part 1. The fine-tuning memory crisis. So where on earth does all that memory even go? Let's break down why training these things is just so hungry for resources. Okay, this is really where it gets interesting. Take a look at this. For what we'd call a small 7 billion parameter model, the actual model weights, the thing you think is the biggest part, that's only about 15% of your memory usage. You need another 15% for the gradients, for the learning part. Then a whopping 31% gets eaten up by the optimizer states, especially if you're using something like Atom. And the biggest piece of the pie? Over 39% goes to the activations during the forward pass. It adds up like crazy. Part 2. LoRa, a clever shortcut. So clearly this memory crisis needed a totally different way of thinking. And that's where the first huge breakthrough came in, a technique called LoRa, which is just a brilliantly clever shortcut to get around this whole mess. So what exactly is LoRa? Well, it stands for low rank adaptation. And the core idea is honestly genius in its simplicity. Instead of trying to update all 70 billion weights in the model, you just don't. You freeze them. You don't touch the original model at all. Instead, you inject these little tiny trainable matrices, we call them adapters, into each layer of the network. And those tiny adapters are the only thing you train. Here's a great way to think about it. Imagine the pre-trained model is this massive, perfectly built superhighway. It works great. Now, LoRa doesn't come in and try to tear up the asphalt and rebuild the whole highway. No way. All it does is build a small, efficient little side road, a detour, if you will. And that side road is just enough to gently redirect the traffic, that's the model's behavior, to get you exactly where you need to go. And the impact of this, it is just staggering. Just look at the numbers for a single layer. Instead of wrestling with over 16 million parameters, with LoRa, you're only updating about 131,000. That is a 99.2% reduction. Let that sink in. A 99% reduction in trainable parameters for that one layer. All of a sudden, you're getting the same fine-tuning result with just a tiny, tiny fraction of the work. But, of course, there's always a catch, right? Here's the thing. Even though you're only training that tiny little side road, you still need to have the entire highway loaded into memory just to use it. And for a 70 billion parameter model, just loading those frozen weights, that still takes over 140 gigabytes of VRAM, which for most of us is still way, way more than a normal GPU can handle. So we're not quite there yet. Part 3, QLoRa, pushing the limits. And this is where the next big idea comes in. QLoRa. It takes the absolute genius of LoRa and just cranks the efficiency knob all the way to 11. So QLoRa, or quantized LoRa, it adds one more amazing trick to the pile. It starts by asking a really smart question. Hey, if we're not even training the big base model, if those weights are just frozen, why are we wasting all this memory storing them in high precision? And so QLoRa takes that frozen base model and shrinks it way, way down to just 4 bits. The result? It instantly cuts the model's memory footprint by a massive 75%. Just like that. And it pulls this off with a few really clever innovations. First, you've got this special 4-bit data type called normal float, or NF4. It's basically tailor-made for the way weights are distributed in a neural network, so you lose less information. Second, there's this wild idea called double quantization, where it actually quantizes the numbers used for quantization. It's like Inception for saving memory. And third, it uses something called paged optimizers, which is just a slick way of moving stuff over to your regular computer RAM when the GPU gets full, so you don't crash. It's a whole stack of smart ideas. Part 4, LoRa versus QLoRa, the head-to-head. Okay, so now we have these two awesome techniques. Let's put them side by side and see what the real practical differences are. Honestly, this table says it all. Just follow the row for a 70 billion parameter model. Full fine-tuning, an impossible 1.8 terabytes. Forget about it. Regular LoRa? Okay, that helps a lot. It gets us down to 280 gigs. Still, that's serious enterprise hardware. But QLoRa? Look at that. It brings it all the way down to just 40 gigabytes. Suddenly, that's something you can do on a single high-end gaming or workstation GPU. This right here, this is the technique that blew the doors open for everyone. So at the end of the day, it really boils down to one core trade-off. On one side, you have LoRa. Think of this as the maximum quality option. You're probably going to get slightly better performance, and your training will run a little faster since there's no quantization happening. On the other side, you have QLoRa. This is the maximum savings option. I mean, 75% less memory is huge, and it's what makes fine-tuning on consumer GPUs even possible. Part 5, from training to production. All right, that's all the theory, but the big question is, how do you actually decide which one to use for your project? Let's turn all this into a simple, concrete plan of action. So, when should you use standard LoRa? Simple. Use it when quality is your absolute #1 non-negotiable priority. And of course, when you actually have the VRAM to spare. It's also a great choice if you're doing a ton of quick experiments and that iteration speed is really important, or if you're just working with smaller models, like a 7B, where the memory savings from QLoRa aren't quite as life-changing. And when do you reach for QLoRa? Well, this one's even easier. You use it whenever memory is your biggest bottleneck. If you're on a consumer GPU, if you're trying to keep your cloud bill from exploding, or if you're tackling one of those giant 30 billion plus parameter models, QLoRa is pretty much the default choice. The only thing you have to be okay with is a potentially tiny, and I mean tiny, like 1 to 2% dip in quality in exchange for those incredible memory savings. Now, this is a really, really important point to get. QLoRa is primarily a training time trick. Its main job is just to make the training process possible on your hardware. But once the training is done, you don't have to keep it quantized. For production, you can actually merge those little adapters you trained back into the original full precision model. That way, you get the absolute best inference speed with no quantization getting in the way. So what's your actual plan? It's super simple. Here it is in 3 steps. Step 1, just start with QLoRa, always. The memory savings mean you can experiment and iterate so much faster. Step 2, when you've got an adapter you're happy with, merge it back into the original full precision model for production. And step 3, only if you test that merged model and find that last tiny 1 to 2% of quality is absolutely critical. Only then should you even think about rerunning that final training pass using standard LoRa. So as you get started with all this, I want to leave you with one final thought. Out of all the different knobs and dials you can tune, there's one that makes or breaks your model more than almost any other, the rank. Just think of it as the bandwidth you're giving the model to learn. If you can get that one hyperparameter right, you're already 90% of the way there. Get that right first.